Okay, so I guess I'll erase that. And let's look at the series for just this step where we're going from 2 to 3, and it loops back on itself 2/5 of the time, and it advances 3/5 of the time. Okay, so how often does it take one step?
3/5 of the time.
3/5 of the time it takes one step, and then
3/5.
how many often does it take?
2/5 times 3/5.
2/5 times 3/5 takes two steps,
Mm-hmm.
and then
2/5 times 2/5 times 3/5.
okay, and then what are we gonna do?
Well, do the same thing. So we pull out the 3/5 and we
Okay.
add that back in at the end if we need it. If it doesn't
We
work out.
multiply it back in at the end. Okay, 3/5, and then I got 1 plus 2/5 times
2
2 plus 2/5 times
3.
2/5 times 3 plus 2/5 times 2/5 times, writing in between this thing is hard. 2/5 times 4.
Mm-hmm.
Okay.
And then we're gonna just ignore the 3/5 and just look at the inside series.
Uh-huh.
And we set this equal to x.
Right.
And we multiply both sides by 2/5.
Okay.
And then subtract. So we're gonna get 3/5 x.
Do you follow those steps?
Yeah.
Because we're low on room. I can write them out, or if you see them, I won't write them out.
I think I see it. because
Okay,
you
so we set the
X,
inside equal to x
And then you multiply x by 2/5.
by 2/5, and then
So
I get a
every-
series that shifts over this way.
Yeah.
Mm-hmm.
And so it's 2/5 times x. When
Equals.
sorry, it's not. It's
That's
3/5.
3/5.
So you got to subtract.
Subtract it.
3/5 times x equals
1 over 1 minus 2/5.
equals
Or the series.
1 plus 2/5
So
plus
2/5
2/5 squared,
So-
which is 1 over 1 minus 2/5.
So 5/3.
So this ends up equaling 5/3.
Okay, that makes more sense.
Okay, so at the second step, to go from 2 to 3, it takes how many steps on average?
So
Five.
5/3.
5/3 steps.
So
Okay, so let's look at our chart now and see. We got one missing.
I think I see
Mhm.
something.
0 to 1 to 2 to 3 to 4 to 5. So this on average takes,
1
or 5/5.
5/5.
interesting. Okay, 5/5. This loops back on itself 1/5 of the time,
It takes
and
5.
it goes 4/5 of the time goes this way. And how often did that take?
5/4.
5/4. This loops back on itself 2/5 of the time, advances 3/5 of the time,
Takes
Takes
5/3.
5/3. This we don't know yet, but it does loop back on itself 3/5 of the time.
Advances
This
2/5.
and then this loops back on itself 4/5. It advances 1/5 of the time, and you said if it advances 1/5 of the time, this should ought to take 5.
Which would be 5 over 1.
5 over 1. And so now what's your guess for this one?
5 halves.
5 halves. And where do how do these expected values for number of steps going forward relate to the probability of going forward?
They just
Just
did the
the
reciprocal of the
The
probability.
reciprocal. Yeah. So how many boxes of cereal do we expect to have to buy to get all 5 coupons?
So it's whatever the sum is, and then if we need to round to the nearest integer.
Well, no, the expected value doesn't have to be added.
Okay, so it's
B.
this sum.
6 plus these 5/4 plus 5/3 plus 5
Okay,
halves.
so 5/5 plus 5/4 plus 5/3 plus 5 halves plus 5 over 1.
And we could just we could factor out the 5 on the top.
So it's 5 times a fifth plus a fourth plus a third plus a half plus 1.
Well,
By the way, do you see a formula in general now if there were 10 coupons?
so it's just whatever your number of coupons is, and then you have the series that goes up. So like if your number of coupons is n, it's n times 1 over 1 plus 1/2 plus 1/3 all the way to 1 over n.
Yeah. Okay, but we should be able to sum this pretty quickly.
Well, let's see. So 1 plus 1/2, 3 halves, plus a third, that's 11/6. So it's 1/2 plus a third is 5/6.
Okay.
So it's 11/6.
11/6.
Plus-
So it's 9 plus 2.
Yeah.
Okay.
Fourth, so let's see. That would go into 12, so that'd be 22 twelfths plus 3 twelfths, so it's 25 twelfths.
22 twelfths. So we got 25 twelfths.
Mm-hmm.
This goes into 60ths.
So
So
it'd be 125 over 60.
I guess
60, so it'd be 137 over 60.
and then times 5 at the end.
Yeah, 137 over 60.
Times 5, that would be 137 over 12.
What's the nearest multiple of 12 here?
132, 12 times 11,
So it's 11 plus
5
Five
times.
twelfths.
5 twelfths.
So it's
So it's a
around
little,
our original guess.
little underneath 11 and a half. Alright, so I wrote a little computer program that we're going to take a look at now.
Okay.
To see how this plays out. Alright, this is great work, guys.